Hello and welcome to episode.
Episode.
Well, no, we started today 50 minutes ago on episode 4. So this is episode 7, which will be out on Monday. On a Monday. No, on a Friday. On a Friday.
Right, this time we're doing this little module we got come up. Let's see if I can get this. This one will be really hard to get focused in on. A little teeny weeny. The device is actually at the top here. It's a little black device and it's a Thermistor.
Yes.
Although you didn't change it on the screen, I did sort of show it on the little screen on the top right.
Yeah.
It's not really a lot to look at to it.
It's not enough lot to look at.
So, and I've already pre-wired it. I've not, we've not got the software running, but
yeah,
Dean will go through the.
I'll go through that in a second. Yep, I'm just adding in the thermistor to the pole, which you'll just see pop up now.
There you go. Next one in.
Nice live editing, just how we like it. So, if we were to switch to this, to the code is.
It is quite complicated, some of it.
It's only 54 lines.
Now, yeah, it starts off average. You define in your thermistor, which is your analog zero, but then you define in thermistor normal with a 10k. Basically, it's done via a voltage divider.
Yeah.
Whereas, so you've got 10k. The thermistor's supposed to be 10k. This one might not be. I don't know, because it's trying to be something else. But then it works out between the two what the actual resistance is, and as it drops so much resistance per degree whatever, then you can mathematically work it out.
Yeah.
The code continues on, mentioning that you've got this beta coefficient, and the other resistance here uses 10,000, which actually I happen to know this has got a 10k on it. And to try to improve the readings, I've set the number of samples of 10, so it's 10 readings.
Yeah.
Averages out between them, and then we'll give you what the average is.
Yes.
Then it obviously just prints on the thing. But there is a bit I think that you wanted to mention. It's quite a large.
The Steinhardt equation. Yeah. It's basically just a method of converting a number that pulls out from an Arduino. So all the Arduino is actually receiving at this point is a voltage.
Yeah.
It knows I sent out 5 volts. I'm getting 3.4 back.
Now on this, what we're actually done on this is we run on some 3.3 volts.
Yeah.
So what I've actually done is I've tied the 3.3 to the AREF.
Yes.
So it's got an analog reference voltage.
So
it knows it's pushing out 3 volts, and then it knows what it's getting back.
And then it knows the difference. It just basically works out.
You can put it into the 5 volt, but the readings are a little bit more erratic.
It is. So just upload. There's nothing really to talk about.
That Steinhardt is a nasty. You can look it up online. It is a really nasty equation, and that's why some people don't use it. I've seen a lot of people use a matrix array of variables. So they'd say, right, if it's this voltage, then it must be this, and they just work it all out for themselves. And this is what this one's pushing out.
This one's pushing out 24.52ish.
Now, there is something I found on this one. Like, if you watch this, and you can let them know what the values change. You see, ready?
Yep. 26.17, 30.23, 31.05, 32.58, and
so it's going to ones that are not quite actually right. It doesn't actually quite do it.
Boom! I get the biggest jump.
So it's very bad. I have actually tried shooting my inhaler at it, which is quite cold.
Yeah.
And it still continued to rise because it's not very accurate.
Right.
But that could be partially down to the wire lengths.
Yeah.
But also might be because if the thermistor isn't a 10k.
Yes.
Then your depending on how much you know about electronics here, because you're using a potential divider,
Yeah.
you're dividing it, so you've got the positive at one end, ground at the other, midpoint. If you
Yes.
put 5 volts there, well, say 10 volts there, 0 volts there, midpoint, you should get 5 volts coming out.
Yeah.
If you have a resistor between there and there.
Mhm.
Yeah.
Yeah.
If they're both resistors the same value.
Yeah.
So 10,
Yeah.
and so the resistor offset on this which is 10, plus the 10 on it, so you've got 10 either side of your potential divider. So when the what comes out the middle should, if it's at the position when it should give out 10k,
Yeah.
would give out 5
Yeah.
on the reading, because there'll be a 10 and a 10, which would be 5.
Yeah.
So, and then obviously as you imbalance, you've got one fixed resistor, as this is the variable resistor basically,
Yeah.
your values of voltages will fluctuate accordingly.
So one last thing before we do end, as this is the last one, guys, borrow your phone.
Oh no!
So we do actually have a thermometer in this room attached to a wall. So if you just come over here with me, I will show you that the rather wibbly wobbly that the temperature in this room is
21
between
something.
21
Oh, actually, if you look up
and
at the
24.
clock above, it's actually got a digital version. What time it says it's 22 degrees.
So that up there, don't you see that says it's 22 degrees. That says between 21 and 24, and our display is pumping out 24.41.
So it's a bit out.
But obviously that could well be because of the temperature of the resistor itself.
Well, anyway,
As it heats
we
up.
don't need this one now, do
We
we?
don't need that now, no, because we are finished recording for the day.
Yeah. So I'm gonna
It's
turn that
only
one off.
taken us an hour and 3 minutes.
Hey, it's done.
But it's done, so we hope you enjoy the episodes. Unless you never see these episodes, in which case you wouldn't have enjoyed them, but you would have enjoyed the alternative version. So yeah, we will see you at some time in the near future, or the past, or the present, whenever.
So for now, I'm going to take this and I'm going to lob it in our little box.
To never be opened again.
Not coming out of there until someone votes for it to be used.
We'll see you later.